Hello everyone. In this video, we will be discussing a numerical from module 2. So module 2 bar elements only we usually discuss. Since many problems already we discussed, just for a change, in this video I will be discussing the rod element. So what is the major difference means? Correctly speaking, both rod and bar is same only, but wherever the word rod element is used, along with the element stiffness matrix, a few more things we have to find out, that we will see. So what is given and what to find. So this problem, consider a bar or rod which is shown in sketch, determining the following by hand calculation. Number 1, displacement at point P, strain and stresses, element stiffness matrix, strain energy in element. So usually when you see the bar element, of course they have given in this bar only, that's why I said both rod and bar element are same. But the word rod indicates along with this the nodal displacement, stresses, strains and reaction, we are here calculating what? Strain energy also we are calculating. So almost same thing only. So we'll have you look on the given problem, I mean the sketch. When we see the usual problems where the left hand corner, usually from there only the dimensioning starts, but here for a change x1, x2 and x, where the starting point itself is having a distance of 15 inches and the ending point x2 is 23 inches. They are asking out to find out the displacement at some point in between x1 and x2. That distance they have denoting it as x. So the length given at the first point, that is node 1 and node 2, as 15 inches and 23 inches at now we cannot call this a length, that is the point magnitude. So correctly speaking, the length, that is from this point to this point, it is 5 inches, and from this point to this point it is 3 inches. So that is the length. And Young's modulus value is given 13 to 10 power 6 gigapascal, and Q1 Q2 value, that is displacement at this point is given directly in the question itself. So it will be easy for us to calculate because only one unknown is there, so it is easy for us to calculate. So Q1 and Q2 given as 0.02 and 0.025 inches respectively. The unit they have maintained is as inches, so they are not converting into mm or centimeter. So that's why even in the Young's modulus also they have kept it as psi. Area value, same cross section from one end to another end, so it is 1.2 inches square. Okay, we'll see how to solve this problem. I think it's very clear. The length, there are 3 different points. First point, second point, the nodal displacement is given. In between the point only we need to find out the nodal displacement. That is the first case. Second thing is strain and stress for this element and this element we need to find out. And third is the element stiffness matrix, that is from x1 to x and x2 x2. So these two elements, element stiffness matrix we need to find out. And last one is nothing but a strain energy. So that also we need to find out. So point like step by step we'll find out. First one is the displacement at point B we need to find out. So now you see this whether it is a linear or non-linear. So the given condition is very clearly understood that it is a non-linear. So sorry, it is a linear. So we will be going with the linear shape function equation, because the shape function can be defined as it is also called as a kind of interpolation function, where we will be finding out the unknowns between two nodes. So this is in between these two nodes only. At this particular point only the shape function we need to find out. So for the linear shape function equation, what is the equation? We know that. So we know that for any particular point P, the Q displacement can be defined as Q is equal to N1 Q1 plus N2 Q2. So luckily in this problem Q1 and Q2 value is given, and N1 and N2 value. So that we need to find out by using the formula. We know that what is the linear shape function equation for the 1D element. That particular equation we need to use, and we need to find out N1 and N2. So the value calculated as 0.375 and 0.625. Q1 and Q2 value is given in the question itself, that I will be substituting. Then I will be finding out the displacement at point P. It's very simple. Only thing is you should be remembering what is the n1 and n2 formula, the shape function formula for a 1D bar element which has the two nodes. Next asked is strain and stresses is asked. Strain is denoted as this epsilon symbol and stress is sigma. So a strain can be calculated by using the formula 1 by x2 minus x1 minus q1 plus q2. It's a common formula for the element wise we can able to find out. So I know what is x2 and x1 and I know what is q1 and q2. Easily I can able to find out strain, and it is a unitless quantity. So the 6.25 into 10 power minus 4 is the strain value, and the stress value Young's modulus into P into Q, that is the nodal displacement at point P, whatever we have calculated that value. So 30 into 10 power 6 and P into Q, it is 6.25, this one 6.25 into 10 power minus 4. So if you are multiplying this one, means stress value will be getting us 18.75 into 10 power 3 Newton per inches square. Next is element stiffness matrix. We have a very simple equation, that is AE by L, 1 minus 1 minus 1, 1. Just now I said A value is known, E value is known, L the total length value. For the, they consider it as a single element, not two element. So the total length is 8 inches. So 1 minus 1 minus 1 1. So if you are simplifying this one, means we will be getting 4.5 into 10 power 6, 1 minus 1 minus 1 1. So this is the element stiffness matrix. Either you can take this inside or you can keep it outside. So this is the value actually they are looking for, and again K we are getting in the inches unit. And the last part of the problem is nothing but strain energy in the element. Strain energy in the previous videos discussions I already discussed. So how to calculate the strain energy is nothing but U equal to 1 by 2 transformation matrix, that Q is the transformation matrix, that transforming into the global stiffness matrix into the transformation matrix Q. So I know what is the Q. It is Q1 and Q2. So Q1, Q2, which is written as the normal displacement matrix. So Qt is the displacement matrix transpose. So 0.02, 0.025 is the Q matrix. That transformation will be this column. I need to write in the row 0.02 then 0.025. K value is 4.5 into 10 power 6, 1 minus 1 minus 1. Here what they have done is they have taken 4.5 as it is. Yes. Then they have multiplied this, and finally a single digit value they have got, that is nothing but a strain energy. So this is how. If you are not comfortable with the units what I have used in this problem, you can go with the comfortable units which you are feeling. But make sure that all the data you are completely converting into the same unit. That is important. The shape function formula you have to remember. Strain equation you have to remember. Stress is a common thing. Element stiffness matrix equation again is a known thing. And strain energy is formula. So this problem additionally you need to remember strain energy equation, shape function n1 n2 for the a 1D element which have two nodes, and the strain equation also you can remember. If you know the stress value, just divided by E, if you put that also you'll get strain. So you need not to worry about strain equation. So shape function equation and strain energy equation is important to remember this thing. I hope there is no doubt, because as much as possible as many problems we have discussed. So I guess it is very clear. Just have a look on this formula. So thank you.